This is Ren Zhu from your network science class. This is my video for assignment 3. This is the chart for degree distribution. This is probability. This is degree. I did all the calculation on Excel. This is my file, my data. And move to the question 2. It's about the trade-off between node degree and local cluster if coefficient. I color the node degree. You can see these black circles. They have the highest degree because they're darkest, they're black, and the dark gray, the light gray, the almost white. And I weigh the LCC value. So the bigger the circle is, the bigger the circle are, the higher the value they have, the LCC value. So what is the meaning of the LCC? It's a measure of the neighborhood density. So basically it means, for example, this white circle, it is big, right? So that means it has a pretty high probability that any of its neighbors nodes are connected with each other. So it makes sense because these big circles, they are in huge amount. You can see in this diagram the highest degrees, right? They have a low probability. So this is 10. So they have a very high amount, a very large amount. So that's why they have a pretty higher probability that their neighborhood are linked to each other. So move to the question 3. It's about the trade-off between closeness centrality and betweenness centrality values. So I color the closeness centrality. What is closeness? What is the meaning of the closeness? It's a measure of how close is a vertex to the other. So basically it means that how long it will take to spread the information from one node to the other node. So take this 3 black circle as an example. They are black, so they are the darkest color. It means that they have a very low, they have lowest distance to all the other nodes. It means they are connected with almost all nodes. The betweenness centrality is a value of the number of shortest path a node is part of. So these 3 black circles, they also have a very high betweenness centrality. It means that they are in part of many shortest path between 2 nodes. So move to the question 4. It's about different communities and eigenvector value, I think, eigenvector centrality values of nodes. Yeah, so you can see there are 4 colorways: black, dark gray, light gray, and the almost white. So the color separate them into 4 categories. The eigenvector, what does it mean? What's the meaning of the eigenvector? It's a measure of the degree of the vertex and the degree of its neighbors. So it basically means that the influence of a node that has on the network. So take this black nodes as an example. They are pretty big circles, so it means that they have a high eigenvector centrality value. Thus, they have a very high possibility that pointed by I'm sorry. They are pointed by so many nodes. So for example, this one, it has a bigger circle than this one, so it means that it is pointed by more nodes than this one. So move to question 5. These are my results: the average path length, the network diameter, the modularity scores. So that's all. Thank you for watching.